Hello viewers, welcome to Magesh chemistry classes. This presentation consists of Pinacol-Pinacolone rearrangement. The topics covered in this video session is what is Pinacol-Pinacolone rearrangement and what is the mechanism and the migratory aptitude of the groups present in it, problems, stereochemistry of the Pinacol-Pinacolone rearrangement, and finally we will discuss some of the questions asked in TRB-PG related to the Pinacol-Pinacolone rearrangement. The last year PG, there were two questions had been asked in Pinacol-Pinacolone rearrangement area. We will discuss with clear explanation at the end of the Pinacol-Pinacolone rearrangement session. Let us move into the video topic. What is Pinacol-Pinacolone rearrangement? It is a conversion of this type of compound. It is nothing, it is vicinal diol. In the presence of acid on heating, it gives a ketone type compound. It is pinacolone. And this vicinal diol is called Pinacol. So Pinacol-Pinacolone rearrangement is the intramolecular conversion of the diol in presence of acid to give the ketone type compound pinacolone. Here the various reactions taking place are dehydration with molecular rearrangement. So in this reaction, dehydration of this diol takes place. In addition to that, molecular rearrangement. And one more reaction there is a 1,2 shift also takes place in the Pinacol-Pinacolone rearrangement. So shortly, it is conversion of phenocol. It is nothing, it's a diol to the phenacolone. The medium is H plus. In some cases, it will be Ag plus and NH2. That is nitrous acid. If NH group is present, the nitrous acid also a reagent. So these are the additional reagents used in this place. So in common, it is H plus. Here the dehydration and 1,2 shift also takes place. So these are about the definition of Pinacol-Pinacolone rearrangement. Let's see the mechanism of the reaction. In the mechanism, the step 1, the protonation of the OH group by the acid. Let us take this type of this phenocol is protonated. The one of the OH group is protonated to give this type of species. And which OH group is protonated, which depends upon the stability of the OH ion. It will be discussed later. So this is the deciding factor. The step 2. In the step 2, the protonated phenocol loses water molecule to form the carbocation. So the water molecule is lost, you get the carbocation. The formation of carbocation is a very important step in the Pinacol-Pinacolone rearrangement. So the intermediate is carbocation. In the step 3, there is a 1,2 shift takes place. The carbocation formed is unstable. To attain the stability, it undergoes some sort of 1,2 shift. Here it is a secondary carbocation. By shifting up this methyl group to this place, you will get this CH3CH3CH. Okay, so there is a tertiary carbocation formation takes place. So this is more stable, so that the shift takes place. In the first step, the resonance of this carbocation takes place. The lone pair electron shift towards this area, so you get the protonated ketone is obtained. In the step 5, in the next step, the protonated ketone is deprotonate to give the phenacolone. So this is phenacolone and this is the catalyst. So in this way, the phenocol is converted into phenacolone by intramolecular rearrangement. Here the 1,2 shift and carbocation formation, protonation and deprotonation takes place. Let us see some examples and problems in this area. The first one, predict the product, this type of the phenol. Here the two methyl groups, the two phenyl groups are formed. To predict the product, you have to keep in mind two important points. One is the formation of more stable carbocation formation, and then the second one is the migration of the group. So which carbocation is first found, then which group is migrated first. See here two OH groups, which one is protonated first. So it is the first step in the Pinacol-Pinacolone rearrangement, which is protonated, which carbocation is found. When the plus is found here, the two methyl groups are present. When the plus is found here, two phenyl groups are here. So it is resonance stabilized. So the carbocation formed is this type. That is CH3, C, CH3, OH, C plus here the pH is formed. So this stable carbocation. Then this methyl group, there is the two methyl groups are present and there is no migration of groups. Priority is not followed here. So two methyl, either of the methyl is shifted. That is 1 to methyl shift. You will get the product like this. pH, the methyl group is shifted. So this is the product. So two important category you have to remember. One is the formation of carbocation and also migration of the groups. Okay. The second case. Here the two phenyl groups are present and here the two hydrogen atoms are present. When the plus is found here, it is CH2 plus. When plus is found here, two phenyl group. The phenyl is stabilized by resonance. So the carbocation is like this, pH, C plus pH. And the OH is present. Then either of the hydrogen is shifted here. So phenyl hydrogen shift, that is pH, C, pH, here it is H, and it will be C double bond O. So this is the product. The stable carbocation is on this side. So carbocation formed is pH, ethyl group, methyl. The phenyl OH is protonated and it will be carbocation. Then there are migration of the group. Which one is easily migrated? So the methyl and ethyl is present. So the migratory aptitude is very important. Here the migratory aptitude is in the order. In case of alkyl, then the primary is more than the secondary than tertiary. Here the ethyl group. So ethyl group is shifted. CH3, it will be CO and this ethyl is shifted here. So this is the phenolcolone product. Why this stable carbocation is again rearranged? What is the reason? The reason is the unpaired electron present in the oxygen pulls the group present in this carbon to the other side, so that the 1,2 shift takes place. The example 4, the phenyl and here one PHOMe is present. You know the first of the stable carbocation formed is from this side or this. Here the two phenyl groups and here one phenyl and one OMe is attached. It is an electron releasing group. Again it is stabilized by the resonance and so this stable carbocation is found first. MEO, PHC, pH plus here it is pH and OH. What is the second? It is a migration of this phenyl group to that side. So the phenolcolone is like this. C double bond O pH. So this is a phenolcolone. Next topic is migrating aptitude of the group. Here the hydrogen is greater migrating aptitude than phenyl than R. In case of alkyl group, tertiary is greater than that of secondary than that of primary. The most electron rich or the more substituted alkyl group migrates first. In case of phenyl ring, electron donating groups are present which enhances the migrating aptitude and the electron releasing groups are present which decreases the migrating aptitude. Then we see the problems in the cyclic system by using this migrative aptitude nature. The Pinacol-Pinacolone Rearrangement, the cyclic system. So first consider the fifth one. The 4-member cyclic system, the diol is present. The first H plus is protonated and the migration of the group. See, the first formed carbocation is like this. So here OH is present. So it is carbocation. And this is COH, stable carbocation. Now the migratory group is present in the second carbon atom. Here the one of this bond is shifted to this carbon, so that you get the member 1, 2, 3, 4, 5. The ring expansion takes place. The first one is as like this, such as the second one will be the 5-member, and the ketonic group is present here. Okay, so this is the type of phenocolumn. Here the ring expansion is taking place. Let us see this example. It is symmetrical one. Here it is 5-membered and 5-membered. The examination point of view, you can write the product like this. So it is a 5-member, and to the other 5-member ring is expanded to the 6-member, and in the alpha position there is a cardinal group. So this is the product. Okay, here the 2 members are in the same size, and the 6th problem also the 2 members are in the same size. And see the 7th member, here one is the 4-member ring and another one is a 5-member ring. Which one is going to be expanded? The lower ring is going to be expanded. So you can predict the product like this. So it is 5-member ring assets. To this it is expanded. So it will be the lower member is converted into 5-member, and another 5-member is like this. To the alpha position, the carbon group is present. So in the examination point of view, when the 2 rings are in same size, one of the ring is expanded and the carbonyl part is present in the expanded ring. See the 5th one, the ring is present in the carbonyl group is present in the 5-membered ring. Okay, when the rings are dissimilar in size, rings are different, the expansion takes place. The lower member is expanded and the cardinal group is present in the lower member. So this is the basic of the cyclic system. So cyclic system also Pinacol-Pinacolone rearrangement takes place. The examination point of view, you can very easily predict the product. Now the Pinacol-Pinacolone arrangement in the cis diol, 6-member system. When it is treated with acid by heating, what is the product? 2 things are very important. The OH axial will be easily protonated and it will form carbocation, and trans to the leaving OH group migrates. In order to understand clear, this is written in the formula like this. So cis for the 1-2 system, axial equatorial axial is the cis, and axial or equatorial is the trans. It is a cis. So one is in the axial form and another one is in the equatorial, and this is the 2-methyl group. Okay, when it is treated with H plus, what happens? The axial is easily protonated and it will be carbocation. So it is a methyl group and it is OH group. Here the CH3 and it will be removes as carbocation proton. Then the migration takes place. Migration, the trans to the leaving group. It is the leaving group. So it is a trans place. So this methyl group is migrates. So this methyl group migrates here, and this will be ketonic. So during migration, the configuration is retained. So here it is C double. So this is a type of drug product. It is similar to that of clear. Then the transdiol. It is a transdiol. So in case of transes, it is axial and equatorial. Equatorial is more stable. So I have taken in the equatorial format. So this OH is equatorial, and here the OH is equatorial, and the two methyl group. Okay. When it is treated with the H plus, what is the product? So either of the OH groups are similar. Any one of is converted into carbocation. So here two axial groups, and it is plus, and here the equatorial OH present. It is the leaving group. So for the leaving group, the trans to the leaving group migrates. Here there is no leaving group, so it takes this carbon bond. So this is migrates here. So what is the product now? It will be like this. So this system will like this. So the movement of this group, and it is converted into the carbonyl group. So the methyl group is present here. So this is equivalent to 5-member system, and to this methyl group, and this is present. Okay. Here what is the conclusion? The cis diol in Pinacol-Pinacolone rearrangement gives a product like this. And trans diol, there is no anti-periplanar trans group is present in it, and so the ring is contracted to give the 5-member product. Okay, here the ring contraction takes place in case of trans diol. This is very important for the competitive aspect. Okay. So regarding stereochemistry of the Pinacol-Pinacolone rearrangement, the OH group is axial, will be easily carbocation, and the trans to the leaving group will be migrates. In the cis form, the product, and the trans form, the ring is contracted. This is very important. Okay. Next, see the questions in the TRB-PG 2019. So it is a question from TRB-PG 2019. The product obtained in the Pinacol-Pinacolone rearrangement reaction of cis-1,2-dimethyl cyclohexane diol with H+. So we have already discussed cis-1,2-dimethyl cyclohexane diol. So cis, the same place, and the methyl in the below the plane. So it is cis-1,2-dimethyl cyclohexane. It is similar to the ring structure. So the 1,2-di substitution, axial equatorial is the cis, and equatorial is the trans. So here the OH group in the axial position and in the equatorial position. Here the two methyl groups are present. When it is treated with the H plus, what happens? The OH group in axial is protonated, and it will be carbocation. So it is plus, it is the equatorial methyl group, equatorial OH group, and methyl group. It is a leaving group. The trans to the leaving group migrates to the carbon. So it will be ketone part, and here it is methyl, and it is methyl, the equatorial methyl. It is similar to that of the 6-member, here 2 group, and it is ketone. So what is the product? It is a cyclohexanone. So it is not a cyclopentane. So D is not the answer. C is not your answer. Then 2,3-dimethyl cyclohexanone. So the two methyl groups are in the same place. It is 2,2-dimethyl cyclohexanone. So A is the answer. Okay. So this is the TRB-PG 2019 question. The compound which does not undergo Pinacol-Pinacolone rearrangement is. So for Pinacol-Pinacolone rearrangement, there is a diol system. Here there is a diol system. So this compound undergoes Pinacol-Pinacolone rearrangement. Here the diol system in the form of NH2, when it is treated with nitrous acid, this compound will be converted into OH, CH2, OH. And so you have the diol system. So this compound exhibits Pinacol-Pinacolone rearrangement. When this compound is first treated with the AgOH, it will be converted into this OH and here CH2OH. Again we get the diol system. So this compound also exhibits Pinacol-Pinacolone rearrangement. See this compound here present, here the first carbon, the second one it is third carbon. So 1,3 diol is present, 1,3 diol does not undergo the Pinacol-Pinacolone rearrangement. So diol only, 1,2 diol is the basic reactant to undergo Pinacol-Pinacolone rearrangement. So this compound does not involve Pinacolone rearrangement. So your answer is D. Okay, guys, we have come to the end of this slide. I hope that it is useful to you. Thank you for watching.